This lesson is about frequency distributions, so let's just plow on into that. It does start to get into some mathematics. So a frequency distribution, sometimes just called a frequency table, has categories of whatever was being measured, along with the number of times a data value fell into that category. So this would be very similar to probably when you were in the past at some point in time you've done tally marks, and then we just count up those tally marks and see what the full frequency is. This helps us understand the distribution, and the distribution has to do with, we have lots and lots of data values, so we want to find out which categories have the most data in it, which one have the fewest values, so that we can see kind of which categories are the most important, or if we were trying to analyze some sort of a service feature like we have here at the bottom of the screen, you know, maybe where we should set our goals along the way. So this comes from, this down here at the bottom, this comes from some data from McDonald's lunch drive-through service times, and they were measuring time in seconds. They're supposed to be a fast food place. So when you're seeing 124, you're looking at 2 minutes, 4 seconds really there. And how long do people have to wait then for their service? Most people wait between 75 and 224 seconds. That's where most of the values fall. There are some people that have to wait more than 225 seconds. The most common response was between 125 and 174 seconds. So, you know, you can think about that and think, well, most people then are waiting just over 2 minutes, but under 3 minutes. So 2 to 3 minutes for the full service. We're going to come back to this data as we go on a little bit more, but this is what a frequency table looks like then, or a frequency distribution. To build one of those is more complex than you would think. We have a lot of terms that we get along the way. We have lower class limits, upper class limits, and then class boundaries. The lower class limits are the smaller numbers, and so if you go along right in this area here on the left of this table, you see 75, 125, 175, 225, and 275. Those are the lower class limits, which kind of implies that each one of these categories then is a class. The different section you divide it into is a class, and we have a lower class limit, and then the upper class limits are these higher numbers, the ones that all end in 4s, and so they're listed out there. But because if you think about math and algebra and a number line, there actually are numbers between whole numbers. So there's something between 124 and 125, right? So where is that line when they're rounding it off and they're going to round it to the nearest second? Where is the line drawn? The line happens to be right in between those boundaries. So if we have an upper class boundary at 124 and the lower one is at 125, then we've got one at 124.5, the halfway mark in between those. But to continue that on, then we continue the pattern. Even though 75 is the lowest one and there's nothing in between, we go down another 0.5 and at the end go up another 0.5, so that from whatever your limits are, your boundaries are in between those other values. I mean, if it's the endpoint limit, then you still continue the pattern to create another boundary. So boundaries are not on your class limits, but they're the line in between them. Midpoints. The class midpoint is the value that's in the middle of the class. Like, so between 75 and 124, the value exactly in the middle of that class is 99.5. How do you find the midpoint? The midpoint can be found by adding those two numbers. So like 75 plus 124, 75 plus 124 divided by 2. And that's what gives you your midpoints. So the midpoint is the middle number. You could possibly just figure it out by counting in, but it's going to be most efficient. Add and divide by 2, like you're finding just an average of two numbers, although average is not really a term I should use in this class. Class width is the difference between, now be careful about this one, this one's a common mistake, but it's between two consecutive lower class limits. It could be 2 consecutive upper class limits. But what you don't want to do is just use one class, because that's going to throw you off a little bit. So here we see 75 and 125, and 125 minus 75 is 50. Take 2 of the lower limits in a row, or even 2 of the upper limits in a row, and subtract them. But you need to make sure you're on a different line. Otherwise, if you just subtracted across one, you're going to get 49, which is incorrect. So it's like once you have that lower class limit, you add 50, add 50, add 50, add 50. And then we can do the same thing on the next side. So we have now class midpoints and class widths. Don't forget, these are lower class limits, upper class limits. The ones with the 0.5s were the boundaries. If we have like 124.5, 174.5, those were boundaries. The ones that is the midpoint, then you add and divide by 2. And if you need the class width, then you can subtract those lower class limits. So if you have a lot of data and you are trying to construct a frequency distribution, you have to first of all decide how many classes you're going to make. And that, there's no set answer. It's usually somewhere between 5 and 20. If you have fewer than 5 classes, it's like, why were you even bothered, and just split it up anyway. And if you have more than 20, it's just a little bit mind-boggling to look at a graph like that. And so we just try to choose a number that's in between there that seems to work with your data. Then you want to decide what the class width should be. And it's really not just, that's not an arbitrary decision. You can select the number of classes, but you have to calculate the class width. What you do is you take your highest data value minus your lowest data value and divide that by the number of classes you want to make. And whatever answer you get, round it up. And it says round it up to a convenient number because it's supposed that your class width ended up being 42.6. Well, it's not very convenient to make the class width be 44. It's usually easier for people to think and read your charts if they're going up by numbers that are easier to count by, like count by 20s, count by 50s, count by 25s. Those sorts of numbers are typically the types of numbers that we use for class width. So it would be just awkward to have a class width of like 13. Nobody counts by 13s. They could count by 10s, possibly 15s. But we're just wanting this to get rounded up to a convenient number. So the high minus the low divided by the number of classes, and then rounded up to a convenient number. Then you choose the value for the first lower class limit by either using that minimum value or a convenient value below the minimum. So that seems, I know when it says just or a convenient, it doesn't seem very clear, but we're going to go back and look at our McDonald's distribution and kind of see that in just a minute. So those are the steps in constructing a frequency distribution. Now, what do we do after? Because we left this one off with choosing the first lower class limit. Well, after you have your first lower class limit, and you already know how wide it's going to be, you can list the other lower class limits by just adding. I'm going to remind you of this real quick. Like if we go from 75, we go 125, 175, 225. That's just adding 50s. And then we figure out what the upper class limits will be, which is generally just back up one, because we know what the next lower is, and so we can just back up to get that one. And then we take the individual datas and put a tally mark in the class, and then we add those tally marks to get the frequency. Now, I have a little step. As we go through this, a lot of times you're going to see little notes from, besides the statistics, just some extra notes I put on the slides. You don't actually have to do all of these steps in your homework, but you do have to do parts of them, or when they show you something, you have to be able to interpret what they did and know what's next. So maybe they show you the lower class limits and they ask you what the upper class limits will be. Or maybe they give you the first lower class limit and they ask you what the other class limits will be with the width. So you do have to do parts of it. You're just not going to have to do all of it at once. The actual data from the McDonald's lunch service times is in this table. Now, the first step was select the number of classes. And I've gotten and read what they did, But rather than that, let's just first of all consider how many there are. There are 3 rows of this, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, 17 times 3 would have been 51, so we have like 50 data values. So if they've got 50 data values, now you can see where they might use 5, because they might start off by thinking, well, maybe that'll distribute it so that we have everything in there, but you've just got to decide where you're going to go with that. So 50 data values, you don't want to use, more than 20, and that's not going to divide up very well. We do want clumps of service times. So that's what they just decided, use 5. Now to calculate the class width, you have to take the high value minus the low one and divide it by the number of classes. So you have to really kind of look at your data very closely to find the highest one here at 308, and then find the lowest one, and the lowest one was the 83, and it's right over here. So the high minus the low divided by the number of classes. Now this came out to 45, so they could use a class width of 45, but again, this is not a number that people easily count by, and generally the convenience of it is using something that people easily count by, and so they just used 50 instead, okay? And that was just because it would be easier to add up the things. Then they have to choose the value for the first lower class limit by using either the minimum or a convenient value below the minimum. Now again, the minimum was 83. So they had to pick, let's either start at 83 or let's go down. So they chose to start at 75 because again, you're typically trying to do something so that it's easy for people to understand and easy to follow along with what you're doing. So they could have used like 50. 50 would have been another reasonable start because then they're going to be using a class width of 50 and it would have gone, the lower limits would have gone 50, 100, 150. But they chose to use 75. So there is sometimes you're just choosing something convenient there. And that's where our 75 gets put on the chart. So that's, after all of these steps, that's where they've started. Now, as you're finishing up, what happens is you want to use the first lower class limit and the class width to do the other class limits. Since our class width was 50, and we've already decided to start at 75, notice here in red, this is just, they keep adding 50, 75 plus 50, 125 plus 50, 175. So they're just adding 50, and this gives us the row of numbers that is in the very first column of our chart over here. Once you know the first number of your second class, you can back up to get the ending number of the first class. So if the second class starts at 125, the first one ended at 124, and so forth. And so we have then our upper class limits, and we can put all of those in the table. Then this is where it can be a real pain if you actually are doing this by hand. You've got to figure out how many of each data value falls in the appropriate class. So that would be a real pain to count through, and you'd need some tally marks along the way. You would just be saying, okay, I'm going to look at this data and I'm going to make a mark for everything that's between 75 and 124. And when I say between, it's inclusive. It includes the 75, includes the 124. And so if we're just looking along, there's 1, 2, 3, 4, 5, 6, and so on. Okay, I'm not going to, we'll save us the misery. And this is where the frequency comes from. And that is the full frequency distribution. Now, when you have a frequency distribution table, a lot of times the next step, or sometimes just even before it's published, is to turn it into a relative frequency distribution. You actually have to have the frequencies before you can do this. But what happens is, rather than telling you the number or the frequency that something happens, they turn it into a percentage or a proportion. So in order to take a frequency distribution, which is the one here on the left, and turn it into a relative frequency distribution, we have to, first of all, add up the total frequencies so that we know the number of values. Now, I actually did that on that other thing where it had all the raw data out there, and I calculated, okay, there's 50 values. So here, if you summed these up, there would be 50 values. After you know that, then you take each one of these values, the frequency, divided by that total, and that's going to give you a decimal. Move that decimal over 2 places, which is the same thing as multiplying it by 100 to get a percent. So here, 11 divided by 50 is 0.22 times 100 is 22, so it's 22%. 24 divided by 50 times 100, we get 48%, and so on. It's just your frequency divided by your totals frequencies, and then turned into a percentage, and that's called a relative frequency distribution. In other words, if you only saw the relative frequency, you would certainly know where the most values happened, but you would no longer know how many data values they had. Now, a cumulative frequency distribution is another chart that you can make from a frequency distribution chart. But rather than telling you how much happens in each individual class, it keeps a running total. And so like here again on the left, we have that same frequency distribution. And on the right, we have a cumulative frequency distribution. And so it's like telling you how many you've had so far. There were 11 in the first class and 24 in the second. So by the time you finish the second class, you've had 35 so far. And so on down. So you just keep adding. And so this very last number should match your total frequencies. So your cumulative frequency lets you make sure you've counted for all of them. It doesn't as clearly illustrate the data, but that certainly is something that's used sometimes. One thing that is handy about that is because if you can see your total right here is 50, then I know half of that's 25. So I can easily see that I've already gotten half of it done before I even finish the second class. So more than half of it's in these first two. Whereas over here on your irregular frequency, you would need to add those up to find out how many there were first. It's just not used as often, but that's cumulative frequency. One of the things we said at the beginning is that a frequency distribution lets us determine how the data is distributed. The word distribution in statistics, or how the data is distributed, both refer to where are the most of them, where are the least of them, what does this look like, you know, if we graphed it, kind of a thing. Our most important concept that we use is a normal distribution, and normal has a very specific meaning in here. The frequencies start low. Now I've got this little graph, sort of an icon here, and then they increase, and then they decrease. So the number of frequencies is low, then they have the most of them happen in the middle, and the least of them on the ends. So when you're talking about a normal distribution, and you're going to need this information, it starts low, it's highest in the middle, it ends low, and it's approximately symmetric. You're definitely going to need all that information as you're going through your homework. The distribution is approximately symmetric, which means there's kind of a fold line in the middle where the left half could fold onto the right half and it would match up. Normal distributions, we wish would fit this perfectly, but often they're just kind of close. And so when you are looking at frequency distributions, you get asked things about, is it normal or is it approximately normal? So the next slide is to help us figure that out. One of the things we can do, and the next section actually covers it more, but one of the sections we can do is turn a frequency distribution into a histogram. What you're seeing here, I'm not going to go into a lot of detail, but these are histograms. They kind of look like bar graphs, but all the bars touch. We'll leave it at that right now. And then the frequencies are over here on the left. Or this one is a relative frequency where it's got percentages possibly over here. But at any rate, we see short, and then it gets tall, and then it's getting short again. So certainly this one doesn't fit an exactly normal one, but it does start low, end low, it's tallest in the middle. This one is perfect here. This one's as normal as it can be. It'd still be a histogram if it weren't a curve. right? Because this one is balanced. You can see outlining that, we often call that a bell curve, and that might be a term that you've used even if you haven't heard of a normal distribution. This one, normal, pretty much normal. Okay, now this left-hand blue bar is not exactly the same height as the right-hand blue bar, but they're close. So it starts low, ends low, tallest in the middle, basically symmetrical. So we would say that's fairly normal, approximately normal. This one is not even close. There is a different term for this one, but right now you just need to know this one is not normal. It is almost the same all the way across. And of course, I couldn't resist. I have a crazy sense of humor. So does that hat make me look normal? All right, that really finishes up the information, but I have one more slide for you as a homework tip in here, and that is Statcrunch. Statcrunch is, and I'm going to pull up a Statcrunch over here to show you, but that is something that's available in your homework. They have a YouTube channel where you can look up how to do things. Most of this class, I will be telling you how to do things on your calculator. However, right at this point, it's easier to use Statcrunch. When the data is already presented in the column, it does not really make the histogram for you. However, Statcrunch is extremely helpful in taking all of these little data values and rather you having to go through and count what they fit into. Watch what I do with Statcrunch on this particular one. So it brought all of those data values in here into a column, and I'm going to tell it to make a histogram. I want it to take the only column it's got, so I had to click that. And then down here at bins, I'm going to use those classes that are over there. I can see that it starts at 15, and that the class width, well, from 15 to 21 is 6. And then I can also tell it to put the values there for me. Then I'm going to click compute, and bam. But here's what's really nice about it. Not only do you see this distribution shape, which isn't normal, but it's somewhat normal, you can also then just very quickly go over here and fill in those values, because bringing that up again, you can see it's 3, 8, 5, 3, and 1. 3, 8, 5, 3, and 1. All it has is the data value. Then it's pretty easy to do it. So I'm going to do that again just to kind of show you. When it's just this listing of data, open in Statcrunch. It's going to open it up in its own window. And then graph, histogram. Choose the only column you have information in. And scroll down and specialize the bins. These started at 15. And then to get the width, 21 minus 15 is 6. Those are the 3 things you would need to do. Click that column over, just click it, and then give where to start the bin, what the width is. And down here, a little further down, if you want, you definitely makes it easier, is you want to tell it to put the value above the bar so it will count them for you. Then compute. All right, so I hope that that's helpful. Not everybody's going to need it, but again, on this type of problem, it works really well. If we don't have that type of problem, then, but the one that already had the chart, it did not work well on, and you'll just need to kind of analyze the numbers. So there's a quick note.